Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in 8086 microprocessor. We're going to see the interrupt operation and interrupt vector table of 8086. And before starting the interrupt operation of 8086, we have already shared the video about 8051 interrupt operation, right? So I would have explained about the basics of interrupts, what is interrupt and what is the operation of interrupts, how the interrupt execution takes place in 8051. Everything is explained in that video, right? I would recommend you people to go through that video so that you can get a clear picture about what is interrupt, how the microcontroller or the microprocessor will work whenever there is an interrupt, right? So now we will see about 8086 interrupt operation. And before stepping into 8086 interrupt operation, we already know whatever the instruction or whatever program which interrupts the main program, that is called as interrupt. That is, whenever a main program is getting executed, this is main program, and whenever the main program is executed, an interrupt will happen. That is, an interrupt instruction or an interrupt program can interrupt this particular main program execution. So whenever there is an interrupt, what will happen? The microprocessor or microcontroller, it will stop the current execution of the main program. It will go to the location of the interrupt program, that is, we will call it as ISR, interrupt subroutine, and it will serve that particular interrupt. And then after serving that interrupt, it will once again come to this main program and it will start executing. This is the normal interrupt operation, right? But in 8051, right, there will be different steps to perform this execution, and in 8086 there is different steps to perform this execution, but the core concept is same. That is, whenever the interrupt happen, it goes to a different location and serves that particular interrupt and come back to the main program, right? And between this you have series of steps that is going to take place inside the microprocessor, right? So that is what we're going to see in this video, right? So first, 8086 interrupt operation, right? As I said, whenever there is an interrupt, right? Whenever the main program is getting executed, whenever there is an interrupt, it will stop the main execution and it will go to the interrupt subroutine and it will serve that interrupt subroutine and it will come back to this main program, right? And but here, in order to perform this operation, there are serious steps that has to be done, right? So whatever interrupt that is happening in 8086, it will follow the same steps, right? And if you take interrupt in 8086, it will be 256 interrupt. It will be 256 interrupt, that is 0 to 255. So it is 0 to 255. So there will be 256 interrupts. So for all these 256 interrupts, there will be same steps that has to be followed, right? And before that, you have to understand certain important concept. Whenever we say interrupt, every interrupt will have its own memory location, right? So if there is a particular memory location, a particular address for the interrupt, that is called as vectored interrupt. And if there is no a particular address location, right, then that is called as non-vectored interrupt. So here in 8086, all the 0 to 255, that is 256 interrupts are vectored interrupt. What is vectored interrupt? It will have a prescribed memory location that will be saved in the interrupt vector table. We will see that in next concept. Okay, so all these interrupts will have its own memory location, right? And coming to 8086, we know that this main program, right? So interrupt is the one which stops this main program execution, right? But this main program will have a particular physical address. I have already said how to calculate physical address in 8086, right? So for this main program, definitely there will be a physical address. So that physical address, normally it will be represented like code register into 10H plus instruction pointer. That is the offset pointer. When we use code register, the instruction pointer will be the offset pointer, right? So it is CS and IP is involved. What does it mean? That is code register and instruction pointer, right? So this physical address, whenever we say physical address, right, the upper part of the physical address that will be saved in CS, and the lower part of this physical address will be saved in IP. So for this main program, you have an address, that address will be saved in CS and IP. Clear with that? Right? Now, whenever we need to serve this interrupt, it will go to this interrupt subroutine. We know that, right? So for that, in 8051, what it will do is it will push the address of the next instruction to the stack, and after serving the interrupt, it will pop that particular address back to the processor and it will start execution. But here, what we have to do is it will have different steps here. The first thing is it will push the flag register. That is, as soon as it stops the main execution, it will stop the main program execution, right? What it will do is it will push the flag register. So why it is pushing the flag register? Because in 8086, right, whatever operation it performs, right? Say for example, if you're doing any arithmetic operation. So after end of the arithmetic operation, based upon the result, the flag register will get updated. Correct? That is, if there is carry flag, if there is carry, then carry flag will be enabled, right? If there is carry between lower bit and the upper bit, then there will be auxiliary carry flag will be enabled. Like that, each and every flag will be enabled depending upon the result, right? So here, whenever the interrupt has to be served, right? After serving the interrupt, the 8086 must come back to the main program and start the main program from where it left, right? Say for example, it stops here and then it starts from here, correct? So it should start from this particular point where it left, right? So at that point, it has to have the same condition. The flag register has to be same condition. So the first step, what it will do is it will stop this main program and it will copy the flag register, that is the status of the flag register, that is pushed to the stack, right? That is the very first step. And as soon as it pushes the flag register, what it will do is it will clear the IF and TF bit, right? What is IF and what is TF bit? I have already explained in previous video. IF is interrupt flag and TF is trap flag, right? So why it is clearing this IF flag and why it is clearing the TAP flag? That is because it is already serving the interrupt, right? So you know what is IF flag? IF flag is nothing but whenever the IF flag is enabled, then it means there is an interrupt. So here it is already serving an interrupt. So what it will do is it will make this IF flag and TF flag to 0. It will clear it. That is the second step. It will push the flag register and it will clear IF and TF. And we know that the main program, the physical address, it will be saved in CS and IP, right? So while coming back to this main program, it has to start from where it is left. So this particular address, the address of the next instruction, right, which will be in CS and IP, right, that has to be pushed to the stack, right? That is the third point, pushed to the stack, right? So now you are very clear with this. It will pushes the flag register and then it will clear the IF and TF flag and then it pushes the CS and IP. Why it pushes the CS and IP? It is where the address of the next instruction will be saved. Correct? Right. And apart from it, now it has to go to the interrupt subroutine and it has to serve, right? So this interrupt subroutine will have its own address, correct? It will have its own address. That address will also be saved in a CS and IP, correct? So it will load the CS and IP of ISR. It will load the CS and IP of ISR to the microprocessor. Got it clear? All these are saved in stack, right? And then it will load the CS and IP of the ISR to the processor. Now what it will do, once it is loaded, the processor will start serving this interrupt subroutine, that is the address pointed by this particular CS and IP. It will start executing that particular interrupt program. And once it completes that interrupt program, there will be IRET instruction, right? Interrupt return instruction. That instruction, what it will do is same like 8051. We know that we have already pushed this CS and IP, right? That is the instruction, the address of the next instruction that is going to be executed. So as soon as it reaches IRET, what it will do is it will pop the CS and IP which is already in the stack to the processor, right? And since we are using IRET instruction, it also pops the flag register, the same status of the flag register where it is while executing the main program, right? So the same status of the flag register, that is also popped to the microprocessor, and the execution of the main program will continue from where it is left. So this is the operation of interrupt in 8086, right? The same operation, but you have to understand these 4 steps. So why is that I'm stressing these 4 points? It's because whatever interrupt, we are going to see different types of interrupt in 8086. Whatever interrupt that is going to happen, these 4 steps is common. Pushing the flag register, clearing IF and TF, and pushing the CS and IP, and loading the CS and IP of ISR. Clear with this? Right. Now we will see what are the different types of interrupt, right? So as I said, these are the different steps that is going to be followed by the 8086 whenever there is an interrupt. What it does, it executes the interrupt instruction, right? And then how it executes the interrupt instruction, that is, it will jump to the interrupt vector table, and from that vector table it will take the CS and IP, right? And then it pushes the existing CS IP onto the stack of the main program, right? And load the CS and IP of this ISR program, jump to ISR, executes the ISR, and come back to the main program, right? The same thing which I explained here, right? These are the steps which follows once the interrupt has happened.
Thank you students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.